Okay, we'll take a look at confidence intervals a little bit different way. Maybe we know some certain information, but we don't know how many people we should ask or how many subjects to study with. So as we're looking at some of this information, maybe we start to figure out what size of interval do we need? How many people do we need to talk to? So with elections coming up, you hear a lot of this about margin of errors and all that kind of stuff. So let's say that we have this candidate, they want to poll, estimate voter support within 3% of the true value at 95% confidence. So they want to be pretty sure they know about where they stand and within 3% of where they stand. So in order to go get that, they want to make sure they know how many people should I ask. So the first thing we need to look at is it a mean or proportion problem, and considering we want to figure out what percentage of people are in favor of them, this would be a proportion problem. And then what formula is needed? Well, that's where we use p hat plus or minus z star, and then square root of p hat q hat over n. The trick here is we're actually going to have to go figure out n. So MOE, in other words, this is margin of error. But what that is really, we know what our estimated proportion is. The margin of error, right? Here's our estimated proportion. The margin of error is just that value that we're willing to go up and down, right? How much do we want to go up and down? So margin of error is z star times the square root of p hat q hat over n. How much we're willing to waver from that initial value. So in this time question, write the question. So in other words, we want to say we want to be within 3%. So we want our margin of error to be 3%. So we're going to plug in what we know um, right there. So let's go ahead and solve it. All we know right now, we got a z value for 95%, right? We know that's 1.96, or 2 if you'd like to use it. So since we don't have an estimate of p, we're going to use one that will give us the widest possible margin. And that one is using a p hat. In other words, let's just assume it's 50-50, right down the middle. Right? So plug in what we know. So we know 0.03 equals 1.96 times the square root of 0.5 times zero point 0.5 over n. Right? So we take a quick second where to really focus in on the math. Solving this thing, so we got 0.0153 equals the square root of 0.5. Really 0.5 times 0.5 is 0.25 over n. We square that, and then 0.25 divided by answer. N, in this case, should be 1067.1, right? So again, from here, you'd end up with 0.000234 equals 0.25 over n. And what I would do is just set up cross multiply and solve. All right, so you'd end up with 0.00234 equals 0.25n. Divide both sides by 0.25. That's where we're getting this 1067.1. The trick here is you always go up to the next person. So we're actually going to talk to 1068 people. And that should give us the information that we're after. All right. So let's say that, here's another one. Fox News poll estimated that 82% of voters believe global warming existed, and they had a margin of error of plus or minus 3%. So an environmental group comes along, and they want to kind of look at that same information, but they want to use a 95% interval, but they're gonna shrink that margin of error down. They don't want any more than 2%. So let's figure this thing out. First things first, is it a mean or proportion problem? And we're talking about 82%. Right? They're giving us a proportion. All these percentages are flying around. Right? So we want to be within 2%. So we want 2% to be within our z star times p hat q hat over n. Right? This time we actually have a p hat. Apparently 82% of people think that global warming exists. So we're going to use that p hat of 0.82 this time. Right? The last problem, we didn't have a certain guessed or estimated proportion. So this time, so that time we had to use a 50-50. This time we do have a p hat, so we'll use it, right? Excuse me. So 0.02 equals 1.96 times the square root of 0.82 times 0.18 over n. Right, one step at a time. 0.02 divided by 1.96, 0.0102 equals the square root of 0.82 times 0.6724 over n. Square both sides. That gives me 0.00000104 equals 0.6724 over n. I would again cross multiply and solve this thing for n. You'd end up with 0.6724 divided by a really small number. That was 6,457.7. So we'd want to talk to 6,458 people. Right, so if that environmental group wants to close that margin of error, we need to talk to that many people, right? Assuming that it is in fact 82%. Right? Credit card company is about to send out a mailing to test the market for a new card. From that sample, they want to estimate the true proportion of people who will sign up for the card nationwide. So the pilot study suggests about 0.5% of people receiving the offer will accept it. They want to be within a tenth of a percentage point to the true rate, 95%. So how big does a test mailing have to be? So is it mean or proportion? Well, we're after proportions. So I'd like to find the true proportion. Right? Write the question. So in other words, we want to be within a tenth of a percentage point. So in other words, they want to be very, very close. P hat, Q hat over n times z. Right? They're going to be very, very close. They don't want to be very far off. So, excuse me, we got 95% confidence. We have a p hat of 0.5. So let's plug and chug. So 95% confidence again, 1.96. 0.5%, right? 0.005 times 0.995 over n. So we'll do some work here. 0.001 divided by 1.96. We'll square that. And then 0.005 times 0.995 divided by that answer. Big numbers here. At the end of the day, we get 19111.96. So in other words, we want to send this thing out to 19,112 people. We'll take another one. A company claims its program will allow your computer to download movies quickly. To test this, a movie will be downloaded multiple times, and the mean download time, that's a good word to know, mean. It is estimated the standard deviation of download times is about 10 minutes. So how many trial downloads must we run to get our 95% confident interval within a margin of error 8 minutes? So is it a mean or proportion problem? Well, the word mean is in there. It's right there in front of us. So the formula for a mean problem, this is the first mean one we've seen, right? So keep in mind, it'd be x bar plus or minus z star times sigma over the square root of n, or x bar plus or minus t star times s over the square root of n. Now, here's the issue. We don't know the sample size. And if we don't know the sample size, if you remember, to get t star, this was based on degrees of freedom. And remember, degrees of freedom equals n minus 1. Well, the issue here, we don't know n, so we cannot use a t distribution. We're always going to end up using this one, a z distribution. So one nice thing about finding sample size, you don't have to worry about the two different issues. So the margin of error is the same thing. It's how much you want to go up and down. Z star times sigma over square root of n, right? So the question for us, we want to be within 8 minutes. So in other words, 8 equals Z star times sigma over the square root of n. Right. Excuse me. And now it's just a matter of plugging in what we know and going with it. Right? So 8 equals 1.96. The standard deviation is about 10 minutes times 10 over the square root of n. And then we have 8 divided by 19. So we got 0.40, excuse me, 8 divided by 1.96. I'm writing stuff wrong. 4.08 equals 10 over the square root of n. Set up, cross multiply. So we'd end up with the square root of n equals 10 divided by 4.08. Excuse me. 10 divided by 4.08. Sorry, I'm struggling with my calculator. So the square root of n is 2.45, which means n equals, square that, 6.007. This is very, very close to 6. But what we could do, again, just to be consistent, let's just go ahead and say we need to do 7 downloads. Anytime there's that extra little bit, let's go ahead and take it all the way up. You're always going to want to take that up to the next one to be safe. One more example. A soccer ball manufacturer wants to estimate the mean circumference of soccer balls within 1 inch. Determine the minimum sample size required to construct a 99% interval. All right, and we're going to assume that the population standard deviation is 0.25. Again, we have to know sigma because we don't use a t distribution here. So, first things first, is it a mean or proportion? Well, the word mean is in there, so we're going to use it. The margin of error for us is 0.1, and that's going to be equal to z star times sigma over the square root of n. And then let's go ahead and solve this thing up. So 0.1 equals, so go to your t table, 99%, all the way at the bottom is 2.576 times sigma is 0.25 over the square root of n. So now it's just a matter of plug and chug and solve this thing. 5, 7, 6. We got 0.0388 equals 0.25 over the square root of n. Cross multiply. All right, just in case, square root of n times 0.0388 equals 0.25 divided by square that. We end up with n equals 41.47. So in other words, 42 soccer balls.